Here's 9.3, number 5. They give me x is 2t, y is 3t minus 1. They ask me for dy dx, and then this d squared y dx squared thing. As a reminder, this is just the second. A lot of times we notate that as y double prime. It is the second derivative of y. Whoops, undo. It's the second derivative of y. Why do they use this notation here? Well, there's actually two different second derivatives of y. So if I write y double prime, am I talking about y double prime with respect to t, or are we talking about y double prime with respect to x? So that's why they use the notation like this here, because we've got two different things that we could talk about taking the derivative of y with respect to. Anyway, and what value do they ask us for? They ask us at t equals 3. Okay, so I am going to call this part A and this part B, just so we can organize our work a little bit here. Okay, so let's do part A first. I got dy dx is what I'm looking for. Well, that is equal to dy dt divided by dx dt. What I want you to see is that these dt's cancel and leave me with what I'm looking for, dy dx. I always like to write it like this when I'm doing these so that I can see those things cancel and then make sure that I'm doing it right. So, another thing to point out, notice dy dt is in the top, the y one. Dx dt is in the bottom, the x one, in this fraction. Look at how the problem is given to us, and this is how it's typically given to us. They're flip-flopped. The x here is in the top, it's in the bottom there. The y here is in the bottom, and it's in the top there. So be really careful. One of the most common errors that I see with these is that people do this thing's derivative divided by this thing's derivative. So just be careful with that. Anyway, so I'm going to do some scratch work. I'm going to erase it. But dy dt is the derivative with respect to time of this, y. So 3t minus 1. Well, that is just 3. Dx dt is the derivative with respect to time of this, 2t. Well, that's just 2. So, when I come up top, remember I'm going to do, and look, do you see I flipped them here. I put the one that I wanted on top, and the one that I wanted on bottom, the bottom. Anyway, when I do this, I get 3 over 2. And that's my answer. It's just 3/2. So the next part, part B, is to find d squared y dx squared, the second derivative of y with respect to x, at t equals 3. Oh, I should comment. This is 3/2. It's 3/2 all the time, so I don't even need to plug in this t equals 3 in this case. So I can just leave it like that. Now, this second derivative, I need to write, I remember that dx dt was 2. So, let me write out the formula. This d squared y dx squared is d dt of dy dx divided by dx dt. Now there's all kinds of different ways that we can talk about why that's true. I had you guys watch a Khan Academy video, so I think that he did a good job explaining that. You could also think about it as the dt's cancel here, and then this dx will wind up here. So it would be d over dx of dy dx, and then that is this thing right here. Just as a reminder, one way to think about d squared y dx squared, it's d dx and then d dx again of y. So it works out where, like, derivative with respect to x, derivative with respect to x, I would have d dx of y as the inner part. And if this cancels with this and then this lands up top, you can check the algebra on that, then it's exactly what I have here. It would be d dx of d dx of y. Anyway, that's sort of a long explanation for a really short operation that I have to do here. So if I want to derive with respect to time dy dx, remember this is dy dx from the previous part of this problem. So what's the derivative of that with respect to time? Well, it's really convenient that that's just 0. So what do I get? I get, why is it 0? Because there's no t here. This is just a constant. So I derive it with respect to t. It goes away. It goes to 0. So the d dt of this whole space, this whole box that I'm drawing right here, is just getting replaced with 0. So I get 0 over, and then dx dt. Well, remember, I found dx dt in the previous question or previous part of this problem. It's 2. Doesn't matter that much because 0 over 2 is just 0. The only time I would have an issue would be if we'd gotten a 0 in the denominator. Anyway, what does that mean? That this thing's a straight line. It has a slope of 3/2 in the xy plane, and it has no concavity. That's part of the straight line.